you know, I know it's 38, right? But the first field shouldn't give you any problem. So I will do the, let's see, I can do it. Oh, I'm going to have to do it here. Hang on a second. See if I can do it here. I can do it here. All right, so one is simplify. So the bases are different, so there's not much I can do here except for change 4 to the third power to 64. And then multiply those two, and I get 12,192. That would be my final answer. Number 2, bases are the same. Well, I mean, I multiply the coefficients. 4 and 2 is 8. X cubed and x cubed is x6, right? That's it. Next one, x fifth times x3. Remember, x fifth is just a shorter way of writing that. And x cubed is a shorter way of writing this. And we're multiplying, right? It's repeated multiplication. And can I express this in a simpler way? Yeah, x to the 8. I'm pretty sure you don't want to write this out. So basically, the quick way of doing this is knowing that if we are multiplying something with the same base, we can simply keep the base and add the exponents. Likewise, 2 and 2 is 4, right? Multiply the coefficients. X cubed and x squared is x to the 5th power. 6 to the 5th and 6 to the 3rd. And again, I would urge maybe for you to expand it out so that you can understand what exactly you're doing right now and why the answer is such a way. So we have x 6 times 6 times 6 times itself 5 times. Right? So again, if I simplify this 2 simplifies to 1. 6 divided by 6 is 1. This 6 and this 6 is also 1. So all that becomes 1, and I'm left over with 6 times 6 times 1 times 1 times 1, which is basically 36, or 6 to the 2nd power. Okay, so let me read the instructions, guys. And sorry, I apologize. I want to see what the instruction says. Okay, that's just say to simplify. All right. Next, x4 and x7. Again, if you go by the quotient rule, this is what it means. When division where the bases are the same, we subtract the exponents, so that gives me -3. And if we apply the negative exponent rule, right, so to change that to a positive exponent, we're going to throw that to the denominator. Negative exponent becomes +3. So my answer is 1x cubed. Now, you can do it that way, or, again, let me show you another one. X to the 4th is x times x times x times x, and then at the bottom, 4, 5, 6, 7, right? That's 1, that simplifies to 1, that simplifies to 1, that simplifies to 1. So on my denominator, I'm left with 1. In my numerator, I'm left with 1. In my denominator, x times x times x is x cubed. So this is understanding, right, how you got the answer. This, right, is more going straight to the answer. Or the last one is, well, you know that there's 4 x's at the top, and you know there's 7 x's at the bottom. If you cross them out, where are you going to have x's left over? Well, it's going to be at the bottom. How many left over? 3. Don't forget to put the 1 on the top. H to the 0 is just 1. This is also just 1. Sorry, -1. Okay, because this whole thing here to the 0 power, right? This whole thing here, whatever is inside the parentheses to the 0 power is 1, and don't forget we attach the minus sign, so we get -1. Now it's a power to a power. So remember what that really means. That really means y to the 4th times y to the 4th times y to the 4th. Right, and what does that really mean? It means y times y times y times y 4 times, right? 8 times, 12 times. And that's repeated multiplication. Y repeated by 12 times. That's why the answer is y to the 12. But you don't want to do either this, and you don't want to do that. You just want to go straight to the answer. So as long as you understand it, y to the 4th times y to the 4th to the 3rd power is y to the 12. We multiply the exponents. Likewise here, so now make sure you raise everybody to the 4th power. Right, so again, I guess I want to say distributed probably, make sure that, so let me just write this a little bigger, the 4th power. So we're going to raise x to the second power to the fourth power, and I'm going to raise y to the first power to the fourth power. So basically make sure that you multiply. So x, multiply these two. I'm going to put it like that. Multiply these two, and multiply these two. 2 times 4 is 8. And y is, there's a 1 as an exponent. 1 times 4 is 4. Final answer. 6 over 2, x7, x4. So I can simplify 6 over 2, and that becomes just 3. x7, x4, so if you span them out, you're going to have 4 x's at the bottom, 7 x's at the top. If you cross simplify, right, you're going to have 3 x's on the top, and you can rewrite that to x a third. So remember, you get 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. Cross out, cross out, cross out, cross out. You're left with x to cover. And then you don't need this anymore because there's nothing left in the denominator except 1. So that's your answer. 12. So again, 8, 4, x5, x2. 8 and 4 becomes 2. As far as the x's goes, there's 2 x's at the bottom, 5 x's at the top. So when you cross them out, you're left with 3 x's or x cubed on the top. Final answer. I feel like I'm playing Who Wants to Be a Millionaire. Same final answer. Okay, so now this one. Where was I? I think it was 13. So here, again, we have exponents on the outside. So we got, I'm going to write this a little bigger. 2cd. D has a 4, and this has a 2, and then cd 5. Okay, so the first thing we have to do is take care of these exponents that are outside. So remember, let me put a 1 here. 1 on top of the c, and 1 on top of the c. So that 2, we're raising that to the second power, we're raising that to the second power, and that to the second power. And the 5, we're raising that c to the fifth power, and that d to the fifth power. So the quick way is to multiply the exponents, right? So the 2 has an exponent of 1, and 1 times 2, so that becomes 2 to the second power. The c has an exponent of 1, and 1 times 2, so it becomes c to the second. And the d has an exponent of 4, which makes it d to the 8th. All right, so that is gone, and then don't forget times, times, times. You don't have to write that, but and then here c to the first power raised to the fifth power is c5, right? Multiply the exponents, and d has exponent of 1, and again d5. Now I can make some of these, simplify something. 2 to the squared is 4. I have these two c's, right? C to the second, c to the fifth. That gives me c to the seventh. And d8 and d5 gives me d13. Okay. I'm going to skip 14 because I can't see it. Actually, no, just do it. Let me just lower that. So 14 again, right? So again, let me write that here. 2f g4 to the fourth power, and then f and g to the 6. So first thing, 2 to the fourth power. F to the first power times 4 is going to be f4. G to the fourth power raised to the fourth power is g16, right? Because power over powers, right? So we multiply the exponents. F1, this one has power 1, this one has a power 1. They're both raised to the 6th power, so I get f6, g6. 2 to the fourth power is 2, 4, 8, 16. I can multiply these two, right? And that becomes f10. Keep the bases, add the exponent. And the g's gives me g to the 22nd power. Final answer. Okay. So I know that there are 5 x's being multiplied and 1 x at the bottom. So if I cross them out, right, I'm going to have 4 x's left over here. y6 and y2, there's more y's in the numerator, so that's going to be y to the fourth. And actually, I didn't even need this, but I didn't know that before. That's my final answer. And I'm going to do this the long way here, which again, you should at the beginning. If 2, 3, 4, 5, that's what x to the fifth means. 1, 2, 3, 4, 5, 6. y to the 6. That's x, and y squared means y times y. Can we simplify? Yeah. This guy and this guy gone. It's gone. That leaves me x to the 4th, which is what I got here. This guy and this guy simplifies to 1. This guy simplifies to 1. And that's what I have here left over. And that's why my answer is x4, y4. Over here, if you look at the x's, I have 2 x's on top and 1 x at the bottom. So I'm going to have 1 left over on the top. Y's, again, 5 y's on the top and 4 y's at the bottom. You can put it over 1, or better yet, just xy. So again, the long way. 1, 2, 3, 4, 5. X, 1, 2, 3, 4. This simplifies to 1. This and this simplifies. And notice I have just 1 x and 1 y. Okay, next. So it's again, expand the rule. Make sure everything, the denominator and the numerator, is raised to the 3rd power. So that's 4 to the 1st power. So that's going to make it 4 cubed. x5, x to the 5th power to the power 3 is x15. And then y to the 1st power, that's going to be that. That's what I have. At the bottom is 16 to the 3rd power, x to the 3rd power, and then y to the 4th power times 3 is y to the 12th. Definitely a lot of simplifying here that we can do. So, where's my pen? Sorry. 4 to the 3rd power is 64. And then 16 times 3, 16 to the 3rd power, 16 times 3 times 3 times 3, when that equals to, I have no idea. What the heck? 16 times 16 times 16. 4,096. Which you can simplify later on. 4,096. X15 and X3. Well, the 3 x's at the bottom are going to go away with 3 x's on the top. So that's going to leave us with X12. Y cubed is going to be simplified with 3 of the y's that are at the denominator, but there's 12 of them, so we're going to be left with 9. Okay. So over here, and then again to simplify, 64 and 4,096, we can just go 1 over 64. Final answer, 64, y9, x12. So, and then next question. So again, let's apply all that. So there's a 5 to the 1st power, so we can get 5 to the 1st power raised to the 4th power is 4. This time. Where was I? On that problem. So again, maybe if I rewrote it a little bigger, it's easier for everybody to see. Notice that the 5 has a power 1, y has a power 1, 20, x to the power 1, and y to the 5th power, all that raised to the 4. So what you have to do is make sure everybody, all the factors, are raised to the 4th power. So 5, so again, the easy way is to just multiply exponents, right? So we get 5 to the 4th power, x to the 12, y to the 4th. The bottom, 20 to the 4th power, x to the 4th. And then what? X to the 4th, and then y to the 20th. Let's simplify that. Oh, I don't even know. So we get 5 times 5 times 5 times 5. We get 625, and I'll write it over here. 20 to the 4th power equals 160,000. 1, 2, 3, yeah. X12, X4, right? So there's more x's on top. So if you, after simplifying, all these x's at the bottom will be gone, and we're going to be left with x to the 8 on the top. Y4th and Y20, there's 4 y's at the top, 20 y's at the bottom. So after you cross it out, you're going to have more at the bottom. To be more precise, 16. 625, so can we divide that? 1, 2, please say yes, please. please, yes. And you can. So this simplifies to, if you divide 625 by 625, you get 1. And 160,000 divided by 625, you get 256. Nice. And that's our final answer. Y to the negative 7 is simply 1 y over 7. Okay, remember? Okay, so one quick way of thinking about that is just if it's, right, it's currently this is how it's written. Right, so if it travels from the numerator to the denominator, which it did, then the exponent, we change the sign of the exponent. And likewise, backwards, this equals to that. Okay? You can travel both ways. 7 to the negative second power would be 7, sorry, right? Which you will simplify to 1 over 49. This one is one where you would travel, you are in the denominator and you travel to the numerator, so it becomes x to the 5th power, right? So it's traveling to the numerator. And to the 1 over 2 to the negative 4th power is just 2 to the 4th power. And 2 for 8, 2 for 8, 16 becomes 16, right? Moving that, okay, if you want to think about it that way. What is this? 23, bases are the same. We still add. What's 5 plus negative 1? And that gives us 4. X to negative 6, it's going to be 1 over x to the 6th power. x9 times x to the negative 7. Again, we add the exponents. And we get 2. Over here, are they all the same? Yes, they're all j's. And we're adding. So negative 13 plus 4 is negative 9. Negative 9 and 6 is negative 3. So you get j to the negative 3, first of all. And then we're going to rewrite that so we have a positive exponent. And I should have used actually a small letter. So I should this, right? Not capital J, small j. Right, so let's see, 26, all right, 27. 27, I would rewrite. Okay, so you have choices, and again, it's how you prefer. So I know the x to the negative first of all, so I want to rewrite this so that there are no negative exponents first of all. So because x to the negative first power, because not negative, I'm going to put that in the denominator, and that 1 is going to be positive. X to the negative 8 power is negative, so to change that to positive, I'm going to throw that to the numerator, and my exponent becomes positive. So now that becomes 1, 2, 3, 4, 5, 6, 7, 8 over x. If you cut this out and you cut this out, guess what you have left over? X to the 7th, right? And then again, if you rewrite that, you can rewrite it x to the 8th divided by x to the 1st. Quotient rule, bases are the same, keep the base, subtract the exponents. 28, so 52x6. I would, it doesn't really matter, but I see that there's a negative exponent here. Let's change it to positive. So 52 divided by 13 is 4, right? And then x6, and then this, I'm going to throw it up here, and my exponent is going to be positive. Well, that over 1, but that's going to disappear. So I get 4x, x6 times x7 is x to the 13, and that's my answer. Now here, okay, so again, you can just add them and then make your switches if it's negative, or if you can make if you want to make your switches now, you can. So that if you made your switches now, you get f to the 3rd power, right? Because it's negative, you throw the denominator. F to the 2nd power. Let me remove that one. F to the 2nd power can stay on the top. And f to the negative 3rd power goes to the bottom. So that rewrite looks like this, with no negative exponents. Let's simplify it a little bit. F to the 2nd power, and at the bottom is actually, let's rewrite it f to the 6th. So that it truly becomes f times f, and then f 6 times 3, 4, 5, 6. These simplify. So my numerator becomes 1, my denominator becomes f to the 4th power. You didn't have to do this, but it helps understand why you get 1 over f to the 4th power. Or if you didn't like to do that, and you just say, I'm just going to add all of them. So we have f, negative 3 plus 2 is negative 1, negative 1 and negative 3 is negative 4. So we got f to negative 4. because our task is to rewrite all these expressions so they have a positive exponent. We write f to the fourth power, with the f in the denominator, of course. Again, your choice. I am going to switch. So x to the fourth power, x to 9, no negative exponents. Again, hopefully by now you understand the simplify, and that just becomes x to the fifth power. So again, let me write this big 24 over 12, x to the sixth power, that's okay. The x to the negative eighth power, I'm going to throw it up here so that it's positive exponent. 24 divided by 12 is 2, and then x6 times x8 is x to the 14. Likewise, the next one, 3x squared, 12x6, y3. So there's a y to the negative 3, and that guy I'm going to throw here to the denominator. And I have another one. Let's simplify. 3/12 becomes 1/4. That's okay. Times x squared. So allow me to go back here and erase that one because we don't need it. And at the bottom, x6 stays. No, sorry. Whoa. Sorry. Let me restart this problem again. Sorry, I didn't see it. Here's my fraction bar. 3 over 12 is 1 over 4, right? X squared and x6, x to the sixth power. So this and this is going to simplify and become x to the fourth power. And then y3 times y3. Remember, bases are the same. We add the exponent, and that's my final answer. Next one, I like to distribute first. That gets rid of it. So, right, that's going to be applied power to a power. So there's a 1 here. So let's multiply the exponents of each of the factors. So 1 times negative 2 is negative 2. X to the third power times x to the negative so 3 times negative 2 is negative 6. And then the y has an exponent of negative 3. I'm going to multiply it by negative 2, and that's going to give me 6. We are still not done. Anything that's negative will go down. Anything that's positive will just stay. So the y6 stays. 2 to the negative second power goes to the denominator, and then my exponent becomes positive. X to negative 6, and you got x to the sixth power. Can we simplify that one more time? Yes, because y6 stays, x6 stays, and 2 to the second power we can write as 4. Two x4, and let's write x7, y3, and this guy here, I'm going to throw down here to the denominator. So y to the negative 4, it goes to the denominator. Let's see. Let's do the y's. y3 and y4 is y7, right? Bases are the same. Keep the base at the exponent. The x's, x4 and x7, we have more x's at the bottom. We're going to have 3 left over. And 2 over 8 simplifies to 1 over 4. So that's my answer. All right, 4 to the fourth, 1 power, x to the fourth power, y to the negative fourth power. And all that raised to the third power. So, again, that 3 multiplies with each of these exponents. I get 4 to the third power, x to the 12th power, and y to the negative 12. So, 4 to the third power becomes 64, x 12, and then y to the negative 12th power, I'm going to throw it down here. It becomes a positive exponent. Now this one we're multiplying, so this is okay. So again, let me write this 5x squared y times 2x squared y to the negative 3. So coefficient was coefficient. 5 times 2 is 10. We're multiplying, so x squared times x fourth is x6, right? Keep the base at the exponents. And then y, there's a 1 here. Y to the first power times y to the negative 3 powers, keep the base at the exponents. And 1 minus 3, 1 plus negative 3 is positive 2. Sorry, negative 2. Right, so this, the 10 stays, the x to the 6th power stays, but the y to the 2nd power, we're going to throw it down here so that it has a positive exponent. 37. Okay, what is that? 37. It's not 38. Okay, not that. So 37. Again, we're going to multiply -4 times all the exponents from each of the factors that are in there. So let me just write this a little bit bigger. -7, and I'll put 1 over here. B3, c to the 0 power, 3 to the 1 power, a to the 3rd power, b to the 4th power, and c to the 3rd power. All that time to the negative power, -4th power. So power to power. Let's start with the -7. So it's -7 and 1 times 4, -4. So we're going to multiply the exponents. 1 times -4 is -4. A, B, 2 times -4 is -8. B, 3 times -4 is -12. And C would be c to the 0. And I'm just, c to the 0 is just 1, so I don't even need to write that. Take that out. 3 to the 1st power. So 1 times -4 is -4. What is that? A to the 3rd. So that's going to give me a to the -12. B to the 4th is going to be b to the -16. And c to the 3rd power here times -4 is going to be c to the -12. So pretty much all the tops are negative. All my numerators, all the factors in the numerators are negative. All the factors in the denominators are negative. They're going to do a little switch. So everybody who's up goes down. So A12, B16, C12. So 3/4 and 7 over 4, 3, 4, 3, 9, 21. So this is 81 over what's 7 to the 4th power? I have no idea. That equals 2,401. The A's, there's A12 and A8, so that means it's going to have A4 here. B16 and B12, that means we're going to have more B's on the top after we simplify, so I'm going to have 4 left over. And the C12 stays. So that's my final answer. Last one, -2 to the 1st power, a to the 3rd, b to the 2nd, c to the 0 power. 3 to the 1st power, a to the 2nd power, b to the 3rd power, and c to the 7th power. All that to the -2 power. So it's very similar to the problem we just did. So let's multiply all the exponents of each factor. So -2, so we're going to get 2 to the -2, a to the -6, because 3 times -2 is -6, b to the -4, and c to the 0, and we're going to eliminate that. It just becomes 1. At the bottom, we got 3 to the 1st power times -2 is going to be 3 to the negative that. A to the 2nd times, it's going to give me a to the -4th power. B to the 3rd power times, so it's 3 times -2 is going to be b times -6. And c to the -14th power, because 7 times -2 is -14. So again, just like the previous problem, all the factors on the top have negative exponents. So let's throw them down here to the denominator and make their exponents positive. Same thing, the denominator, all the factors are negative exponents. So 3 to the 2nd power, a to the 4th, b to the 6th, c to the 14th. So let's simplify. 3 to the 2nd power is 9. This is going to be -4. A4 on the top, A6. So we're going to have A2 here left over. B6 and B4. So we're going to have 2 B's on the top. And C to the 14th. Final answer. Okay, so again, it's really not that difficult. So it's just, again, applying all the things you know about exponents now. Maybe in one problem, okay? But that is about it.